Welcome to the screencast. This is a brief course introduction to ME201 statics. To get started, I wanted to introduce myself to you. My name is Brother Marr, and to share a few things about myself. First, I graduated in mechanical engineering from BYU. I currently live in Texas with my wife and my one-year-old daughter Rachel. And I enjoy is kind of an understatement. I love spending time with my family. Particularly when we're going on walks around the neighborhood. And here's a picture of us. So there's me and my wife and my one-year-old. I'm not sure if she knows what's going on right there in the picture, but anyways, I love them a lot. So what is statics? Statics is the study of forces and their effects on a system in a state of rest or uniform motion. So what I mean by uniform motion is that the system or the object, the structure, is moving at constant velocity, or in other words, there's zero acceleration. And we'll talk a little bit about that as we go in the course. But for most of the time, we're going to look at bodies or objects at a state of rest, or in other words, they're not moving. So to give you some examples of the principles we're going to cover in this course, certainly this isn't all of them, but we're going to talk about equilibrium of a particle, force system resultants, structural analysis, and friction. So this course really lays out a lot of the foundational principles of engineering. So to give you an example of equilibrium of a particle, here we have a barge with a couple of cranes laying out this pipe here on a dock. And you'd say, Brother Marr, that's not a particle, that's a giant pipe. And you're right. But in statics, what we're going to learn to do is to model that huge pipe as a particle and then determine its resultant forces on the cables that those cranes are using. So pretty cool. Next is force system resultants. So here we have an antenna being supported by guy wires, not to be confused with the guy on the wire. So in each of these wires, there's tension, or in other words, force pulling that tower towards the ground. But because there's cables coming in at various angles, the resultant position of that antenna is vertical. So we're going to talk about how we can model something like this and see how all those forces result in a vertical static structure. So how those forces interplay. Similarly, with structural analysis, we're going to look at things like trusses and bridges, and we're going to look at how the forces within each beam and at each joint interact to provide support, whether it be for a road or maybe like a water canal or whatever's being supported on that bridge. Lastly, friction. I kind of laugh at this because here we have someone skiing what it looks like in Idaho, and if that's true, this would be someone skiing in Texas. Aside from that point, in statics we're going to learn about friction, different types of friction, how friction interplays into various applications. So again, there's not a inclusive list of principles we're going to learn, but that's a decent dabbling of some of the cool things we're going to learn. I'm really excited for teaching this course, and I want to let you know that I'm here to help at any time. If you have any questions, please reach out to me as well as to your peers in a group discussion, and I'll be sure to help moderate those. Or if you'd like to send me a personal message, please feel free. I'm here at any time. Thanks for your time, and I'm excited to learn some statics with you. Thank you.